Okay, so hello and welcome back to another Unity tutorial. In this one, it's going to be very focused on coding. There won't be much stuff going on in the scene, if any. We'll be doing about lists and looping. So obviously you'll have used loops before and you'll have used lists before, presumably. But I'm going to be doing some more intermediate stuff than just looping through a list and so on. So we'll be doing about comparing and sorting, but like custom sorting. So not just by default, it's easy to tell Unity, oh, just sort by number order, make it so the numbers go up in size as you go up the list or down. That's easy enough, but this might be for sorting particular like enum in a class, or it gets a bit more complicated, so I'll show you how to do that. And then we'll show you about like looping through lists, removing items from lists as you're looping, and things to watch out for. Just a general like information video, might pick up some stuff you don't know. So I want to start off by thanking my Patreons. Thanks to Michael, Paul Robinson, Fulborn, and Wesley. If anyone else would like to help support the channel and community, then the link's in the description below. Apart from that, let's get into it. So for this example, I've just got two classes. One's a class, one's a struct. So we've got the class here, which is just where we're going to be doing the looping. And this is a mono behavior. We're going to put it on an object to run the code. And then I've got a struct, which is just going to store some data. So what we'll start off with is we will take this class, and on the void start, we'll call a sort. Actually, we might do it just on a button press. I don't know. It doesn't matter. Let's just go for a button press, so then we can look at our data in the scene, press a button, and watch it sort. So if we say, private void update if input dot get key down key code dot space. We'll go with spacebar, and we'll say sort list. I'll try and make the name a bit different to the already built-in things. So sort our list. So we'll make a function sort our list. Okay. So sorry, my voice is still a bit off. There we go. So for us to obviously sort a list, we need a list to sort. So we might as well just do serialized field private list of type, and this list we're going to have is going to be of type test list data. So you might have a list of items you want to sort, but basically a list of a custom class. So we'll just call it test list datas. Yeah, I don't like the plural because the plural of data is data. We'll just leave it like that. So equals new list, and the reason why you do equals new list is because if you don't initialize a list as a new basically empty list, what happens is it'll say it doesn't exist in the scene. If you try and access any of its values, it won't exist. You need to have an empty list before you can add to it. So that's the initialization of the list. And now what we can do is we can have some data, because currently if we went like test list data 0, let's make sure you get the right, so test list data 0 dot, and there's nothing, there's no like functions or variables on it at all. So let's go and make some. So the kind of stuff you might want to sort. Obviously, by default, you would sort, strings and integers. That's easy. All the strings will do alphabetical, and integers will do in size order. But let's say it's a little bit more complicated than that. For example, we're not necessarily more complicated, but we need to have a way to create our own sorting algorithm. So I'll keep it simple for this, but it'll be easier for you to expand and do what you need to do. So let's say we want to sort this test list data by, I don't know, well, let's just add some variables, sorry. So we'll go for public integer x. We'll have should we go for like a vector 3 would be x, y, z. So x, y, z. And then what else might you have? You might have a public string our name. Now, one thing about structs is you can't initialize values like this. You can't set default. Okay, never mind. No, you can't. I was going to say I was wrong there. No, I'm right. You can't initialize values. If you were to do that, you'd have to do it in a constructor. So I'll do that quickly, actually. So the way you would do that is you would say public test list data, so the same type that the struct is, and you would have to put the parameters as whatever you need to initialize. So I'll just say int x, comma, int y, comma, int z, comma, string our name. And then the way you actually set that up is you would just say this dot x is equal to x, this dot y is equal to y, this dot z is equal to z, oops, equal to z, and this dot our name is equal to our name. This dot is the way you differentiate between an x in the class and an x in the parameter. If you just put x, it wouldn't know. I think it assumes it's the parameter if you don't put anything. That's why this works as a parameter. And if you mouse over it says parameter. If you mouse over here, it says field. So that's how you know the difference. So whenever we make a new one of these, we have to give those values. So if we just said like test list data 0 is equal to, or like test list data dot add new test list data. If we initialize it with nothing, all it's going to do is just leave these as basically, well, integers have default values of 0 and strings have default values of just no string. So, well, we can pass in, as you see here when you try and start it off, these different parameters. So we can just say, I don't know, 1, 5, 2, Nathan or something like that, for example. So we've got that in our list. And then, for example, you could add a few more. So we got 6, 1, 8, -5, 21. I don't know. Just put some names in or whatever. So this, well, we could do that on void awake, to be honest. So on the start, we've put these values in our list. Now we might as well, yeah, we'll make that visible. So if we go to the, just give it a second, go to the inspector, make an empty object as our manager kind of thing, and just put on the examples. So currently on list examples, there's nothing here. And that's because this test list data struct is not serializable. So system.serializable. And that means that it will serialize the data, which makes it able to be converted and should appear on here. Here we go. Test list data. And if we press play, because the adding of the things is on awake, we get these elements here, which are our structs. And then if we, obviously we could manually add some in, but I mean, I might as well do it in code, why not? It doesn't matter. So what we want to do now is we might want to sort these values, because obviously they're just random, they're just how they are. Maybe you have some code somewhere with items, for example, where you just add new items to a list, but you want it to be sorted. So you could say test list data dot sort. And when you sort, there's 4 different parameters, and they all look a bit weird if you've never used them before. Now, if you just say no parameters, it will just default to whatever built-in sort they use, which, I mean, in the case of this, when you're trying to sort a struct, what would it go with? I don't actually know what it goes with for this. Maybe it goes for like the first variable it finds and something. I don't know. Maybe it won't sort it. The point is, you want to have control over what you sort this list by when you tell it to be sorted. So what we can do is we can actually write our own function, which it uses as a sort. So if we say private sort func, now this sort function needs to take in 2 parameters, because if you're going through a list, what it does is it basically goes through each value and compares it to the ones next to it, and sees maybe in case of numbers which is bigger, smaller, strings which is alphabetically before or after, and so on and so on. So you want to have the 2 parameters in here, which will be the 2 things that are being compared each time. This function, you don't call it like a normal function. You give it the function to use as logic for sorting. So if we say we want to take in, let's say we want to sort by the name in alphabetical order, right? So what we'll do is we'll say, because if you say a string is greater than another string, as far as I'm aware, it'll do it alphabetically. So we can say string A, comma, string B. Or actually, no, we'll say test list data A, test list data B, and then we'll say if A dot name is less than A dot, B dot our name. No, you can't do that. We'll go with like X and X. I can't remember the way you compare strings like that to see if they're alphabetically before or after, to be honest. I honestly just can't remember. I could look it up, but alright, so if we make this a private int function, so if a.x of the first one we're testing is less than the other one, we'll return -1, which basically, think of it like this. So -1 means before, 0 means the same, and 1 means after, like how you want it in the list. So if A is less than B, you want it to go left by 1. Think of it like that. Else if A.x is greater than B.x, return 1. So obviously if -1 is on the left, 1 is on the right, 0 is in the middle, we're saying if, pretend A is the one you're currently checking and B is the one you're comparing it to. If the one we're currently checking is greater than the one we're comparing it to, then this one's bigger, this one's smaller, and then you can just say return 0 at the end, which means that it's the same. So if you're comparing something which is the same, then just return 0, because you don't care about moving things around if they're the same. And that's our logic for the sort function. We're never going to call this as such, but we're going to put it in here, because this function is designed in a way you don't even have to put your parameters around, because it knows how to treat this in a way that it's a function with 2 parameters of a particular type that this list stores, and it knows how to treat them. Obviously, you didn't have to use A and B as long as you're consistent, but the point is it will use that to sort it. So we sort our list on spacebar. So if we go back, let's press play. So we've got Nathan, Sam, Jack, and if I press spacebar, it goes Jack, Nathan, Sam, and obviously in alphabet, J, N, S. Oh wait, no, I'm looking at the wrong thing here. -5, 1, 6 is what we're comparing, because obviously -5 is smallest, gets negative, goes to 1, goes to 6, and then we could quite easily change the sort function to be, well, we might want to use X, Y, Z, whatever. You basically make your own sorts. So you'll have different variables, right? So you might want to have a variable for an item. You might want to sort your items by strength. So let's say you did have a strength like that, right? You might have saying that X is like the strength variable, for example, on an item. So you want this to basically say if this has got more strength on the item, then we move it this way, and so on. And then we can just say sort by strength, and we just pass that in, and then it'll sort by the strength variable, and so on. You can do it however you want. There are different ways, like as I said, you can sort by character. Like if you do a character array, you can do strings, but this is basically how you would do it in most cases. You would just compare, like this is your own comparison here. This is actually the checking that it's doing, like less than or greater than for integers. So if you were doing strings, you would write your own logic here to be what string goes before what or what string goes after what. You would just replace this. So maybe you just want to, like obviously in strings you can't just check the first value, because if the first character is the same, you then go and check the next value, and obviously so on. There are built-in functions for handling strings like that, but I can't remember off the top of my head, and I don't want to bother going to look strings up. You can do that if you want to, sort by strings. And by default, if you pass in a string, I'm pretty sure .sort will do strings in alphabetical order. I don't know what's under the hood for sort, because it's a built-in thing. You can't actually, Unity hides all that stuff basically, because it's copyrighted, patented, whatever. So one other thing to mention about this like looping and lists thing is that so let's say we've got this list of data, and let's just add like a few more. So minus 54, 22, 7, 62, 30, and 193. So you got all these different ones like this. So you've got all these values in this list. Now, what if at some point you want to remove a value from a list, okay? By looping through and finding something. So we might have a function which we will do like public void remove by name, which takes in a string name. And all we're going to say is we're going to say like go through the list like you would normally do, test list data. I'm obviously going to do it wrong the first way around, so don't worry, I know I'm doing it wrong. So we're going to go through all of them. We'll say if test list data I, so the current one we're checking, dot name is equal to name that we got. We just want to say test list data dot remove at I. Because obviously we're looping through that list in the index, so we're going to remove the one at that index, if that is the right one. And then we can say return because we've removed it. Unless you want to remove all of them, then that's when the problem happens. So I'll leave the return out, actually. So we can just say now instead, remove by name. What I'll do is, I'll just make the name that we remove by as like a parameter at the top. So private string name to remove, and we'll just say down here is equal to, why is, oh yeah, name to remove. Okay, so when we press the button, we're going to loop through the list and remove the things with the name, and we're probably going to get an error, to be honest. So name to remove Nathan. So we're going to try and remove me from the list, right? So when I press, we've got our list, we can open them all up. We press the button and it went through and it removed Nathan, and the others are still there. Now, if we go back, I'm at the start of the list, so I'll be index 1 and remove this. Now the thing is, what this then does is it goes to the next one and checks if the name is right, and if it is, and then removes and so on. Now the problem with lists and removing is, let's say we said we wanted to remove this as well, which is Nathan, or for example, right? Or more importantly, if we did it at the end, what happens is we're trying to loop through this list for a set amount of time, so the length of the list, which is 5. But the problem is, when you remove stuff from a list, the list size changes. And if you're looping through a list 5 times and then one of the things goes and like there's 4, and we're not getting any problems, which is surprising. One sec. Oops. I'm accidentally not getting an error here. So go through the list, and so the test list data.count is what, 5? Okay. So let's say, so what I'm expecting to happen is test list data I shouldn't exist, because if we put a breakpoint in, this is actually the best way to handle it. If we put a breakpoint in and then press play, because what will happen now is it'll pause execution and then we can actually see what's going on under the hood. The moral of this is to loop backwards if you're removing things, and I'll show you how to do that in a second. But so if we go here, we're saying, all right, here's our list of stuff, and we're going to say if that name is the name to remove, then remove it. So remove and go again. So now it's down to 4 things left. Is that the right name? No, don't remove. And then go again. Is that the right name to remove? Nope. Skip it. Is this the right name to remove? Yep. And we're currently on index 3, which will be the last one, 0, 1, 2, 3, which is the Nathan one, because the index 4 moved down to index 3. Oh, that's why it still works. Okay, that makes sense. Yeah, obviously. We'll remove that, and then okay, that does make sense, because what's happening is it's looping for the amount until I is less than the count of that, but because the count is reducing, it actually does stop in time. So that wasn't the best example to give for it. The actual best way to remove stuff safely, because you will get problems where a list, for example, something in the middle will be removed as you're going through a list and trying to get something at a particular index, for example. And what will happen is that thing will disappear, it'll be shifted to another index, and you'll either get a null error or you'll get the wrong thing returned because you didn't expect a certain thing to be at that index as it was shifted. So the way you do this is you would write I is equal to test list data dot count -1. The reason why we do -1 is because in a list, the length is always one bigger than the actual max index, because if you've got a list of 5, then the max index is 4, because you go 0, 1, 2, 3, 4. So you want to make sure you have that. And then we're going to say, while I is greater than or equal to, greater than or equal to 0. Because we want to keep going until we're at 0. We're going down the list. And because we're going down, we want to I minus minus. Now, there is another way of writing this. It's up to you. I've got into the habit of writing I minus minus less than 0. Which basically means, because this I minus minus does the subtraction of I and then checks if it's greater than. It works either way. It's up to you. I'm going to leave it that way. So now if I go down, it's just going to do the exact same thing. But believe me, this way is much safer to do going down, because you will get problems with going up. So, yep. Removed. Let's actually try and do something. How long have we got? What time is it? 21. I guess the other thing to quickly go for is a for each loop. So if we said like for each, and this is going to show the weakness. So if we said for each test list data in test list datas. I can't use that name because that's already taken. For each data in test list data. So that's just referring to the particular one we're checking in the list. We're going to loop through it, and we're going to, instead of like test list data I, like test list data I, in this case is equal to data. That's like what it means basically. So data, we'll say if data.name is equal to name to remove test list data.remove data. So basically remove this one. If this is the name we want to remove, then remove this one. Now, I'm hoping this doesn't work. See, I'm surprised that trying to show something that's bad and doesn't work did work, but it's because it doesn't work a lot of the time. There we go, got the error. So the error is saying now, collection was modified, enumeration operation, is that the right error? I'm getting a different error, I think, I'm not sure. No, it is right, because that's basically saying it can't do move next, because it's going through the list, but there is no next value. Because this is what I was trying to show you earlier with the going up the list. It's kind of the same, but I did it a bit different. Because what happened was I was using remove at index I with the for loop. Like if I actually go all the way back, I hope I can Control Z all the way back. So when I had the original for loop when it was positive, like this. Here we go. So we have this list. Now I was saying remove at I. Let's just say we instead did remove, and then the actual thing we want to remove is test list data I. This, I've already shown you how to loop down, so I'm not going to bother showing you that again. But this is the problem. If you're trying to remove the object, and we press spacebar, and we magically aren't getting the error again. Oh, that just didn't work. It didn't remove all of the things of it. See, it's just a bit dodgy. Just always go with down the list. It's the safest way to go. And if you ever had this problem before and looked it up, people will be telling you to go down the list, because it's the only safe way to go through a list and remove objects. But yeah, I hope you learned something new about sorting, looping through lists, going up and down. It's just a bit of a coding video, structs. Covered quite a few different topics. Kind of a beginner/intermediate video. I'm currently just in need of people's ideas of what they want to see, as I keep saying, because it's like, I go to make a video and I'd love to do things that people want, but I don't get enough comments of people saying what they want, so I just have to think of stuff off the top of my head. But yeah, that's enough for this video. I hope you learned something new. If you did, then leave a like and subscribe, it'd mean a lot. Join our Discord, but apart from that, thanks for watching, and goodbye.